In the early solar system, 3 rocky planets formed of the same materials at about the same time, 4.5 billion years ago. In their infancy, Earth, Venus, and Mars were essentially alike, yet one turned into a torrid, hostile world, baking in an atmosphere of carbon dioxide and sulfuric acid. Another froze and lost all but a trace of its former atmosphere. But Earth sustained its oceans and developed an oxygen and nitrogen atmosphere, evolving into a planet rich in all of the ingredients necessary for life. What happened to our planetary neighbors, Mars and Venus, will tell us more about our own planet and what the future has in store for us. To understand them, NASA is embarking on a decade-long series of missions to Mars to answer key questions about the planet's evolution, climate, and atmosphere. The first of these missions to be launched is called the Mars Global Surveyor. In September of 1997, after a 10-month cruise to Mars, an orbiter weighing no more than 1,500 pounds will be captured in orbit around Mars. Surveyor will then begin a series of aerobraking maneuvers to lower itself into a mapping orbit just 250 miles above the planet's surface. Specially designed by Lockheed Martin Astronautics for the Jet Propulsion Laboratory, Mars Global Surveyor will rely on the drag of the planet's atmosphere to slow its speed and bring it closer to the surface. Aerobraking will take 4 months and many orbits around Mars before the Surveyor is gradually brought into a nearly circular flight path over the poles. Once there, Mars Global Surveyor will begin a 2-year mapping mission, the first intensive study of Mars over the course of an entire Martian year. Mars Global Surveyor's mission is to help enhance our understanding of Mars. Locked within its shifting sands and layered polar caps is a detailed history of the planet's climate, its weather patterns and seasonal cycles, preserved for all to see. By studying the Martian climate, we will better understand what catastrophic events sent the planet into a deep freeze millions of years ago. Those secrets can be found in the Martian landscape, in its rocks, its soil, and its ice caps, the very features that Surveyor is designed to examine. Orbiting the planet every 2 hours, Mars Global Surveyor will point its science instruments down at the surface to study the Martian atmosphere as summers turn to winters. A multi-resolution camera will photograph the entire planet, its surface and clouds, each day, as well as return high-resolution images of selected sites. These strips will be combined with altimeter measurements to create elevation maps, giving scientists valuable new insights into the forces that built the breathtaking volcanoes and immense canyons on Mars. Scientists will study the mineral composition and thermal properties of rocks and ice using infrared images. The images will also show the distribution of atmospheric dust and clouds. Other experiments are designed to explore the crust and upper mantle. The remnants of an ancient magnetic field will be charted, and the deflection of solar wind particles by the field will be tracked. As a new database of information is acquired, the mission will feed the fires of new scientific debates and perhaps lay to rest other long-standing controversies. Other countries are also engaging in this search for new information about Mars. The French are providing a radio relay system for Mars Global Surveyor that will allow the spacecraft to relay data from Russian landers on the surface. Mars Global Surveyor and another NASA mission, the Mars Pathfinder lander and rover, will both be launched in 1996 as the start of a 10-year-long program of missions to explore Mars. With multiple flights to the planet, scientists hope to answer a variety of scientific questions vital to our own future on Earth. As we begin these missions of discovery, the knowledge we gain will become the catalyst for a new educational foundation in the sciences, one that will inspire future generations to continue the journey.